Good morning, students. Today we are going to discuss new chapter that is in 1B, very important chapter, that is about straight lines. What is straight line? Straight line is set of all points which are lying on the same plane in a row. Suppose it is a straight line. This is also a straight line. This is also a straight line. These are our curved lines. This is about straight line. Generally, straight lines are denoted by capital A, B or small l, m, like this. In straight lines, horizontal line which is parallel to earth, that is called a horizontal line, and which is perpendicular to earth, that is vertical line. Vertical, horizontal line and vertical line. If the plane divides into four parts by using a straight line and a horizontal line, like this, the horizontal line is called x-axis and the vertical line is called y-axis. So already learned in lower sections coordinate geometry. In this coordinate geometry, coordinate plane, every point represented by a order pair, and every order pair represents a point, vice versa. Points P, x comma y. Here x is called x coordinate and y is called y coordinate. Abscissa or ordinate. This four parts can be Q1, Q2, Q3, Q4. In order pair, every order pair, if P2, 3 is a point in the plane, then 2 is called x coordinate and 3 is called y coordinate. This abscissa and ordinate, we can call them abscissa and ordinate. Abscissa is nothing but x coordinate. That is the distance from y axis, x coordinate, denotes as distance from y axis. Y coordinates is distance from x axis. Suppose PAB is a point. What is the distance from x axis to the point? This is the distance from x axis, denoted by y coordinate, that is here B. The distance from x axis, y axis is denoted by x coordinate, that is like this, 2, 3. Q, let Q 2, 3. Here 2 points and 3 points. 2, this is 3 and like this we can locate all points. Point on y-axis, x coordinate is 0. Point on x-axis, y coordinate is 0. That is about location of points. Now, if there is a line like this, suppose this is a line A, B, it makes theta angle with positive x axis, then slope of this AB line is, if angle made by line is equal to theta, is theta, then slope of line m is equal to tangent of that theta in positive direction with the positive x-axis. We have to take, suppose there is a line like this. This is the alpha, tan alpha, beta, tan beta, gamma, tan gamma. Like that we can find slope of every line. The slope of every horizontal line which is parallel to x-axis is equal to 0, and the slope of vertical line not defined. That means every vertical line the slope is infinity. We can't define. The slope of x-axis is also equal to 0, and slope of y-axis is undefined. If two lines are there in a plane like this, this is L1 is equal to 0, this is another one, L2 is equal to 0. If L1 parallel L2, that implies slope of line L1 is equal to M1 and slope of line M2 is equal to L2 is equal to M2, then their slopes are equal. M1 is equal to M2. We have to remember this relation. If L1 perpendicular L3, suppose this is L2. If L1 perpendicular L2, that implies M1 is equal to minus 1 by M2, or the product of slopes, their slope is equal to minus. This is regarding about slopes of two lines which are lying in the same plane. We have to use this relation in problem solving. Okay. If another one is there, if there is a line, I am not explain the proof because I already explained in previous sections. Now I am explaining only the relations. If A is a point, B is a point, x1, y1, B, x2, y2, then the slope of line AB. A line, slope of a line passing through A x1, y1 and B x2, y2 can be defined by slope M is equal to the difference of y coordinate by the difference of x coordinates, that means y2 minus y1 by x2 minus x1, or M can be determined by y1 minus y2 by x1 minus x2. Anybody is right. By using this formula we can find the slope of a straight line which is passing through given 2 points. Okay. The next one, if a straight line intersects at A and B, then this line, AB line, intersects x-axis at the point A and y-axis at B. If the coordinates of A are A comma 0 and B are B comma B, then we call the distance between origin to that intersecting point on x-axis is x coordinate, and the distance between the origin and intersecting y coordinate of B is called y coordinate. This is called x coordinate and y coordinate. So x coordinate is x intercept is equal to y, and y intercept is equal to y. That is small a, small b. This is x intercept and this is y intercept. If the straight line is in this position, then this is x intercept and this This is y-intercept, but x-intercept is negative and y-intercept is positive. A less than 0 and b greater than 0. If the line is like this, a less than 0 and also b less than 0, x-intercept and y-intercept both are less than 0. If like this, x-intercept greater than 0 and y-intercept less than 0. These are about intercepts of a straight line on coordinate plane. Now various forms of a straight line. If a straight line passing through origin, what is the x-intercept of this line? What is the y-intercept of this line? Origin is nothing but 0, 0. So x-intercept 0 and y-intercept also 0. So we can say this is only slope form. It has only slope. Slope form, that is first various forms of straight lines. First one is name, or y is equal to mx. Y is equal to mx. So this is only slope form. It has only slope. Does not have any intercepts or anybody. Next one is slope intercept form. It makes theta angle and y-intercept is c. Then slope intercept form, second one is y is equal to mx plus c. Slope intercept form. Here c denotes y-intercept and m denotes slope. The third one is y minus y1 is equal to m into x minus x1. Here slope is there, x1, y1 point is there, slope. That means a point P, x1, y1 and theta is there, it has slope some m. Then this is the equation of this, name of this form is slope point form. Here m denotes slope and x1, y1 denotes a point. Next, fourth one is x by a plus y by b is equal to 1. This is a is here, a is x-intercept and b is y-intercept. This is called as intercept form. We know another one is there, that is a straight line passing through 2 points a x1 y1 and b x2 y2. Suppose this is a line, here a and b here, x1 x2 y2, a x1. What is the slope of this line AB? y2 minus y1 by x2 minus x1 or y11 minus y2 by x2 minus x1, anyway is right. By using m in the third form, we can determine directly a straight line, equation of a straight line which is passing through x1 y1 and x2 y2 is like this. What is there? Y minus y1 is equal to, instead of m we can write y2 minus y1 by x2 minus x1 into x minus x1. If we bring this this side, x2 minus x1, y minus y1 into x2 minus x1 is equal to x minus x1 into y2 minus y1. In this way, we can find this is 2 points form. 2 points form equation of a straight line in 2 points form, or in other words this can be written as x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1, or any one of these in these three, right? By using any one of this form we can find the equation of any straight line which is passing through a x1 and b x2 y2. Already you well known in previous classes, that is in 10th class, 9th class also. In this first year section we have to know two various forms, three various forms are there, new forms, that is normal form and parametric equations of a straight line, and another one is there. We have to know in the next class. First you have to return this in the notes, and you have to remember this. By using this you have to solve so many problems. Okay, bye.